All right, so to finish off this note, just the last example here. So the energy for a damped simple harmonic spring is defined by that equation. So I'm giving you the equation that we're actually going to be working with for this situation. Spring constant's 50, mass is 4 kilograms, and the decay constant B is going to be 0.05 kilograms per second. So for us this year, like I said, it's going to be simplified. You're going to be given them information. So the spring and mass are stretched 25 centimeters and then released. So we'll calculate the energy after half a second. So we do have the formula. That's where we're going to start with EE. It's equal to 0.5 K, that should be delta X squared, E to the negative V T over M. So it's just a matter of doing the proper substitution and interpretation. So 0.5, our K value in this case is 50. We're looking for delta X. Originally it was stretched 25 centimeters. So that's 0.25 squared. E is just 2.71. If you look, you can find an actual E button. And that exponent then becomes negative B, which is negative 0.05, multiplied by the time. So we're looking after 0.5 of a second, divided by our M, which is 4 kilograms. And there we go. Now it's just a matter of practicing with the calculator. So I'm going to tell you that this comes out to be 1.6 joules. So make sure you have a calculator handy that you can calculate it, and if not, I can give you a hand with that in class. All right. B part. What is the energy after 5 minutes? So we got to be careful here, because if you look at our in B part, or sorry, in A part, the value of B is kilograms per second. Remember, in physics we run with SI. So the only trick here is to actually do the conversion. So it's still going to be 0.5 times 50, 0.25 squared, E to the exponent, negative 0.05. Now, 5 minutes, so 5, and we got to go times 60 to get it into seconds, still divided by 4. And this time with the calculator, it should come out to be 0.4 joules. So the damping device that we've put on it, if you take a look, half a second into rotation or oscillation, after half a second, we have 1.6 joules. Okay? After 5 minutes, there's still some energy, but it is slowly being bled off or being absorbed or dampened by whatever method we have in place. All right. Third part and last part I want to look at, and this one's a little bit more tricky. I'm going to have some people panic a little bit here for a second. But I'll kind of talk you off the edge here in a second. So C part, the approximate time for the energy to reach 0. So now we want 0 to equal 0.5 times 50 times 0.25 squared E. And at this point in time, I'm going to keep it simple for the people that are watching here. Let's keep it E to the exponent X. So all that stuff in the exponent, we're just going to call X. All right. So we want to find a value here. So for people that have completed the grade 12 math, this is something you should be able to do. So 0 equals, I'm just going to multiply those numbers that are in front. So 0.5 times 50 times 0.25 squared. So I get 1.5625 e to the x. All right. So as a side note here, okay, recall, with exponentials, the x-axis is an asymptote. So that means that it never actually reaches the x-axis, which means that e to the x will never equal 0. So we're going to have to change that a little bit here, okay? What we're going to do there, then instead, we're going to say, therefore, 0 is about equal to 0.0001. All right, for the arguments of this question, this is where that kind of the higher end math will come into play for you in the future if you ever see this again. So let's just put that in a big red bubble as a reminder how to do some of the, if this question comes up. So what we're going to do then is I'm going to change that 0 to 0.001 equals 1.5625 e to the x. So everyone, that should be the first time that everyone sees that. I'm going to divide both sides by that value there, and I get 6.4 times 10 to the negative fifth equals e to the x. So the grade 12s in this class should be able to solve for x using logarithms. Grade 11s, I'm going to have to talk to you about this. Take a deep breath, don't panic. But basically, you take the log of both sides, log, and like I said, grade 12s, this should be something you're able to do. X log e. And I'm using logarithms for people who are watching this instead of natural longs because natural longs aren't taught till the end of the grade 12 calculus course, but advanced functions, the grade 12 course, they've done logarithms, so they should be able to solve with this method. Isolating for x, we're going to divide both sides by log e. Log e, that's kind of funny. All right, so the left side of the equation is just a bunch of numbers. So if you punch it into the calculator, you will get x equals, so take the log of 6.4, exponent negative 5, divide that by log, and if you can't find that e button, you can use 2.71. So I end up with a value of negative 9.66 approximately. Now remember that exponent isn't just x, so recall x is actually equal to negative bt over m. So therefore, negative 9.66 equals negative b, so 0.05 times, I'm looking for t, over 4. So we're actually, I simplified it. Now we just have to solve for the exponent. So I multiplied my answer by 4, and then divide it by negative 0.05, and I got t equals 770, let's call it 3 seconds, approximately, which is approximately equal to, divide by 60, 12.9 minutes. So it's going to take 12.9 minutes to get to approximately 0. So therefore, after 12.9 minutes, the oscillating will stop. All right. So again, there's two spectrums to this. People who are watching this and know there's more to it. Keep in mind this is introductory material, so we're just trying to give people a feel for the process involved. For people on the other end of it that are right now panicking and trying to figure out how they're going to survive this, you got to keep this in perspective. This is your upper end question, first of all, in an application. Math skills are a big thing here. If you're comfortable with the math, be able to do it. If I have a grade 11 that hasn't seen logarithms before, we're going to talk about how we're going to deal with this specifically. So here's the assigned work. This will finish up this unit. So I wish you luck on the test and on future units. So anyhow, any questions, anything you want clarified, anything that you're panicking about, please talk to me about that tomorrow.